All right, good morning, class. Mr. Clancy here. Nice to chat with you again. I have a short video here that I'd like you to look at as it's on transpiration, and specifically about transpiration. I want to talk about the cooling effect of transpiration. This is an amazing process, a key part of the water cycle that a lot of us, a lot of my students I find are not quite as familiar with when they're when they're kind of reviewing the water cycle like we did yesterday. By the way, a nice job on finishing up on the pages 1 and 2 of that POGL. We're gonna have some additional work on that POGL later on. I'll explain how it works. But anyway, let's look at the definition of the process of what transpiration was. We talked about how transpiration is the process whereby water passes up through a plant, a tree, or grass into the air. Basically, any kind of vegetation will conduct transpiration. The water will enter the roots of the tree. So picture this process now. So it's going to percolate, it's going to go into the ground, be taken up by the roots of the tree, and it's going to move upward via this process called capillary action. All right, so capillary action is how the liquid water will go up the roots, kind of defying gravity, then it will ultimately go back into the environment, back into the air as it departs from the leaves. It goes through some vascular tissue, which is called xylem, X-Y-L-A-M, you can see there. Xylem, if you could picture like a bundle of straws almost, like small passageways, very, very small passageways that allow the liquid water to move up through the tree. It's pretty cool. We also talked about trees will adapt to high moisture levels by growing more leaves, like during a wet spring, so they can sop up more water and prevent flooding in your basement, flooding in areas of the street and so forth. They will also shed leaves in the fall to conserve water, which is really pretty amazing. That's why trees will shed their leaves, deciduous trees. Trees also help keep soil together and stop erosion. They kind of tie the soil together as they're bringing that water. As they're sucking up the water, they bring the water that's in the dirt up through the roots, and then the dirt kind of clumps together so it prevents it from eroding away. An example of that, if you could picture what I call the berm or the small hill at Wheaton Academy, which is adjacent to the tennis courts, it is kind of runs along parallel to that driveway that leads out to the main drag next to Wheaton Academy. It's the hill you go over to get to the upper tennis courts and then the track. There's a berm there, and if you look on the berm, if you can imagine it, or if you're nearby, maybe you live near the school, you could take a walk by. You can see this today. You'll see a bunch of trees that are planted at the top of the berm. Those are strategically planted there to make sure that the berm does not erode away during like periods of heavy rain. It was pretty cool. A little bit more on that tomorrow. So the cooling effect, here's how the cooling effect works of transpiration. I want you to picture water liquid water going through the tree, and now think of it at the top of the tree, okay, where the leaves are, or on the leaves itself, okay? The leaves may not necessarily be at the top, but think about the water on the leaves. It's about to depart, if you will, the tree into the atmosphere. So this is liquid water that's going to evaporate into the air. What does it need to evaporate? Well, it needs heat to evaporate, which is pretty neat. Where's it going to get this heat in order to do that? It will actually extract the heat to evaporate from its immediate environment, from the air that surrounds it. So once the water sops up that heat, it changes its form into vapor and then goes off into the atmosphere. The air around the leaves, having given up this heat, is now cooler. It's just really neat. It's one of the coolest things about the water cycle, I think. And some impact of this amazing concept. I just picked a couple of different concepts for it. One is if you've ever walked in the forest, take a walk in like a nice forest. It's often cooler in there. If you can imagine that. And now some of that is because the trees may be blocking off the sun depending on the sun's angle and so forth. But a lot of the fact that the forests are cooler has to do with the fact that the trees and all the vegetation are conducting transpiration and actually cool the air around it. It's really neat. It also explains partially why cities are much warmer than urban areas. Cities have fewer trees. The trees have typically been cut down to put up apartments, office buildings, factories, and so forth. There's fewer trees means fewer places where transpiration actually does occur. And it's one of the reasons why cities are warmer than urban areas. It also explains, by the way, why flooding is very prevalent in cities, because there's fewer trees to take it up. Many trees now, or many residents in the city, I have a son and a daughter-in-law who live in the city. There's a number of people who are planting gardens now in the city, like on their roof. They can get their vegetables from there. They can grow it. It's pretty cool. It will have a cooling effect. Plus, an added benefit, if you think about it, is they won't have to go to the grocery store quite as often. So that might help in this period of coronavirus. And also, the third application of this I wanted to show you, explain to you, was at Wheaton Academy, as you know, at the soccer / football field, we have artificial grass. There's a lot of benefits for that. It means less maintenance for our maintenance crew, if you will. You don't have to mow it. You don't have to fertilize it. There's all kinds. They don't have to stripe it like they used to. There's a lot of benefits for that. But one of the impacts of that temperature-wise is that the temperature of that artificial grass is going to be that area is going to be somewhat warmer than if grass were there. I know when I started at Wheaton Academy 14 years ago, the soccer field and soccer / football, and for that matter, the baseball field as well, at least the baseball infield, were all grass. So when you have artificial grass instead of real grass, there's less transpiration and the immediate climate's going to be warmer. So the assignment for today is, obviously you're watching this video. There's a second Khan Academy video that I want you to watch. It is basically on the carbon cycle. You'll see that it will tie in nicely with pages 3 and 4 of the nutrient cycles POGIL. So I'd like you, after you watch this video and the next video, I'll give you the 2 links. They're both very short. If you could complete pages 3 and 4 of the nutrient cycles POGIL and upload it, so I'll give you a graded assignment for that. By the way, we are now doing virtual attendance. You probably heard that from other teachers. The way I'm going to do virtual attendance is your submittal of the assignment. So, for example, for this class, I'll be doing the attendance for this class tomorrow. So if you've turned in your assignment, I'm going to mark you as present. So be faithful to the assignments. Do your best to keep up on your studies. Just remember, God honors faithfulness. He will honor that in your life. All right. I miss you guys. Looking forward to seeing you soon. Tomorrow, we're going to talk a little more about the water cycle. And we have a lab we're going to be doing tomorrow. All right. More on that later. You guys take care and have a great day.